Hey, this is Rob Newport with Rapid Analysis, and I'm here with Rocky from TCPoly. And hey, Rocky, thank you so much for joining us.
Sure.
You guys were really nice enough to send me a couple of spools of your ICE9 product. Maybe we could start off with just talking about what TCPoly is, what the ICE9 product is, and a little bit about the filament that you sent me.
Sure. So TC Poly was started out of Georgia Tech by Matt Smith. He's the CEO. And so he basically wanted to develop a thermally conductive plastic that could be used with 3D printers. Um, so through his process and everything like that, we've actually developed a few different lines. We have our standard ICE9 TPU and our ICE9 nylon. So that way we can give customers something if they want a little bit more flexibility and a little bit higher thermal conductivity, or if they need something rigid that can stand up to higher temperatures. We have two different options there. We've also made a few other materials like ICE9 PET G, which was more for molding. So we sell the pellets of that, not just filament. And we actually will make custom material for people. Some people need something that doesn't conduct electricity at all and stuff like that. So if they need something like that, we're more than happy to work with them to develop a filament or, just pellets that will fit their needs.
Very cool. Now, this product got my attention because I'm developing the Xerxes Pi, which looks kind of like this.
Mm-hmm.
And this fits a both a M.2 device on the back and a Raspberry Pi CM5 on the other side. This one is actually just a CM4, but it gets quite hot right here. So I thought, well, maybe I could CNC a aluminium heat sink on it in order to do some passive cooling. And as I did some research, I came across TC Poly. And so I developed a heat sink that pops on
Mm-hmm.
the front. And I thought, 3D printing it might be really cool. So here we are. So
Yeah.
I was thinking maybe we could go over some of the special requirements for printing something like this. Now, could the ICE9 filament be 3D printed with pretty much any 3D printer? Like I have a bamboo 3D printer. Would that work?
Yeah. So our requirements are pretty, I don't know, relaxed compared to something like Peak or something like that. So for the ICE9 TPU, really the main thing is a direct derived extruder is basically the only requirement for that. So you can use an old bed slinger or something newer like the Core XY, like the bamboo and stuff like that. Doesn't have to be enclosed. Now the ICE9 nylon, we do suggest having an enclosure, being able to get up to 300 degrees Celsius at least on the hot ends. Um, and in house, we actually use quiddies because they have a chamber heater. So again, nylon can warp, so that's why we always suggest if you're going to use that, make sure you have an enclosure. But other than those like main requirements, the direct drive for the TPU or an enclosure for the nylon, any 3D printer could really work.
Okay, awesome. So let's have a look. Maybe let's jump into Bamboo Studio and have a look at maybe some settings that we need to tweak in order to get a good print out of it. So I'm just
Sure.
going to share my screen here. Okay, so we've got the heat sink right here in the middle.
Mm-hmm.
And so I made my own user preset, but I noticed that when I loaded up your settings, it kind of just went to generic PACF. Is that correct? Maybe you could guide me through like how I should
Yeah, I
properly
mean,
set this up.
I'm no expert on Bamboo myself, so when I was developing the profiles and stuff, I just started with the default, and so I want to say that's why it's like basically a modification of that profile.
Ah, okay.
Um,
So maybe I'll switch to the PACF generic PACF.
and I will just give a little bit of note. So we actually like to print our ICE9 TPU pretty fast, especially compared to what other people suggest for TPU.
Hmm.
So if you ever look at like a profile we provide, usually it's going to be a modification from a PLA profile.
Hmm.
Um,
Hmm.
because again, they allow higher flow rates and everything like that than just the standard TPU profile. And
Oh, okay.
so, we're able to print our TPU pretty fast on like these fast printers.
Oh, okay. Cool, cool. I did notice that some of the settings that you guys changed included the sparse infill density and the pattern.
Mhm.
Is that right?
Yeah. Um, so again, depending on the part,
And
if it's going to be something that has like infill and everything, you're probably going to want it to be 98 to 100% infill because you want it to be solid to transfer that heat.
yeah.
Um, when we do heat sinks, I will let you know we actually try to design it and print it so we can actually just print everything as a perimeter. So I can go over that a little bit and what we would do something with your part a little bit later here with you.
Okay. Okay. Cool. Cool. Yeah, we've got the part right here, so we could maybe rotate it around or something.
Yeah,
Um, and let's have a look at, so you said speed, and the speed here, it looks like nothing has changed from the generic PACF part here.
yeah.
Um, and then the support we've got on build plate only. What is that about?
So just when we're just sort of designing parts and everything like that, we like to try to use as little support as possible.
Hmm.
And so if something does need a little bit of support, we try to make it to where it's only coming from the build plate. So you're not like having support being built on top of the part to support another piece of the part.
Ah, I see. Okay. And finally, we've got the bed adhesion with the brim width being slightly different and the infill gap being at 100% and no
Yeah.
rib wall. Those are all pretty self-explanatory, right? So
Yeah, I mean, so the nylon can warp, especially if you're doing something. It depends on the part geometry how bad it can warp, but it's always can be a concern. So we like to err on the side of caution and try to use a brim if we think there's even a chance there could be any type of warping and lifting off the bed. Um,
okay, cool.
with bamboo, it doesn't have the heated. Well, I guess their more professional one does have a heated chamber, but the typical ones didn't have a heated chamber, so that's why we're like, yeah, let's usually use a brim for most parts.
Yeah. How hot do you want to heat that chamber if people do have access to a heated chamber? How hot do you want that chamber to get?
Um, we usually run at about 50 C. We've had success at 45. We've had success without a heated chamber, but 45 to 55, you don't really need anything more than that. But we usually run it around 50 C.
Okay. And would you say it's an absolute must to dry the nylon before you print?
Um, I mean, if there's a chance it's been exposed or absorbed moisture, then definitely we would recommend it because your print quality is going to suffer.
Hmm.
Um, because as it's printing, if it's absorbed moisture, it's going to sizzle, pop, maybe a little bit of smoke, and it's going to cause the
Hmm.
surface quality of the print to not be the cleanest.
Yeah, yeah. I saw that drying it out at about 70 degrees centigrade for maybe a couple of hours was the advised drying method.
Yeah,
Does that sound right?
yeah. The only, I guess, uh, little caution I'd say is like depending on what you're using to, dry it out. Try to like keep it away from the the heating element, or maybe put like a foil or something as a barrier if it has to be close. We have had like the spool on a couple of them get warped. We've heard about. So
Oh, if it's too close to the heating element. So you're
you're right.
saying
Yeah.
you use some foil like if I'm
Yeah.
using the heated bed, for example, to heat the chamber up,
Oh,
put
that should
some
be
foil
fine.
on
Yeah.
that should be
Yeah.
fine. Okay, okay.
Yeah. I mean, we've had some people have it where they put in like a toaster oven, which if they're using it for their project and stuff, that's fine. But yeah, when it's so close to those heating elements, it could cause some little warpage there.
Ah, okay, okay. I see. So, if you're in a toaster oven, like keep it
Yeah.
away from the
Yeah.
heating element or like have it be a bit more indirect. But
Yeah.
if
It's
you're
a little bit of
using
shield thing type of thing.
right,
So
right. Okay, cool, cool. Maybe I'll experiment with some different methods after this
Yeah.
segment and report back. Okay, cool. And so here we've got the part sitting
Mhm.
on the bed here. So maybe we'll discuss the best positioning for this. Now, I just thought flat. This is how I printed the just the for placement only PLA version, just to see
Right.
make sure that everything fit properly. But you're saying that this should be placed a little bit differently when doing the actual heatsink print.
Yeah.
And I
I mean,
think
if you
what
do
we
a
want to do
slice
is rotate
preview,
it.
you could sort of see why we would want to change the orientation.
Okay, let's have a look at this.
So if you zoom in a little bit there, so you
Yeah,
can sort of see like the layer lines, hopefully a little bit. It's not showing up too much on my screen, but I know there's there. But so
yeah.
if you think about it, like so our highest thermal conductivity is in plane, not through plane. So
Hmm.
your heat source is going to be like say from the bed, and so now it's having to pass through all these different layers, and so
Yeah,
it has a lower thermal conductivity that way versus if you print the other orientation now, all that stuff that's making contact is in a sort of like in a plane, so it'll have a higher
right.
thermal conductivity.
So if we think of these layers as like little pipes that are moving the heat out, because these fins move in this direction, the heat is going horizontally and it's not moving, it's not pushing vertically out
Yeah, it's just not
of
as
the heat sink.
efficient because yeah, I
So
mean in
then
3D printing, there's
naturally,
always going to be like imperfections and little gaps and air pockets almost, if you will, that are
right,
microscopic, but it slows
right.
down that heat transfer.
So then what if I rotate it, let's see, maybe not that way. If I rotate it like this
Mhm.
and print it like this, then it may be that if we have a look again, we can see that the pipes now are flowing out from the source of the heat and then away from it. So this would probably be a better way to print. Would that be right?
Yes, but there is still one other thing we would probably do for if we were designing or printing it ourselves.
Yeah.
So again, you can zoom in on the part there on that preview, and I can sort of show you or tell you a little bit
Okay.
about what we're talking about.
Right.
So orange is the perimeter, and then that white is like a gap fill, and then obviously have inside perimeter and stuff like that. What we would try to do is we would change it so that it's only printing a perimeter the entire part.
Oh,
So that
okay.
way it's
Okay.
not going back and doing all these gap fill stuff or anything
Hmm.
like that.
I
It
see.
makes a cleaner print because our material is heavily filled. I mean, it can ooze easier than like say a normal TPU or nylon. So
Yeah.
by having cleaner print and less travel movements, it helps with the printing process for our material, but also it will just clean it up the heat transfer because again, now it's having to go from that perimeter through that gap to the other perimeter versus the other where everything is almost like a single past an entire layer.
Yeah. I
If you can
gotcha.
eliminate that.
Yeah. I think maybe I'll do another YouTube segment where I do a deep dive into reconfiguring these settings to get rid of that gap fill and do 100% perimeter, but I'll leave that for after the segment. But that's great advice because it makes a lot of sense. You naturally want more of that heat extraction and using that perimeter instead of that gap fill is definitely going to result in that. So that makes sense. Very cool. Well, thank you so much for talking with me and walking me through this. I think it's going to be really exciting to give this a shot, and I'm definitely going to maybe do some tests as well and see what these different configurations are going to result in as far as heat extraction efficiency. And do you have any like final comments or questions before we end the show?
No real questions, but I did want to just say I actually, I saw your part there, and I did like a little mock-up, sort of showing what design changes we would do. If you want me to share that with you, I'd
Oh
be
yeah,
happy to.
that'd be amazing. Yeah, great.
So let's see here. So again, I wanted to sort of take some of the design elements. I saw you had those and sort of the cutout for that. But obviously, since I was planning for this type of orientation, I have this little chamfer here on this, so that way you're not having to just print up in the air. I go around and do that for here. But what I also made sure to do was everything is universally the same size. So if I go to the preview, you can sort of see. So everything is just one perimeter for every layer.
Oh, very
And
cool. Okay.
so that's something we would probably do, but we'd actually probably go a little bit further, which is what I'm going to show you with the next window. Because again, with that one, you can't really do the vase spiral mode with a continuous like extrusion. And again, we try to do that if possible. Not every design is going to work that way. So, but the ones we can, we like to. So let's
Hmm.
see here. Let's share that one. All right, so here's the other one. So this one, what I did was you have little indents, so you know where you need to like drill out for your holes, if you will.
Hmm.
I also use the, let's see here. Is it quality, I think? Oh, yeah. So I use this arcane wall generator. I don't know if it's necessary, but I know because this is going to be slightly thinner, like a zero
Hmm.
point 0.1 thinner than the rest, it might benefit from that arcane, which can compensate for the small extrusion. But again, when we do the preview on this, so this is now just one continuous spiral vase print.
Mm.
Um, so again, that's something we usually try to do if we can, because it's just going to have the best, thermal conductivity. Again, you don't have any of the gap fill or anything like that, and go from there. But just figured I'd share that with you, a little bit of what we would probably do if we were like, modifying the part for you or anything like that.
Yeah, that's awesome. Yeah. Thank you. I'll definitely give that a shot as well. I'll print that out today. Because
So I think I made that part with like a zero point 0.8 nozzle in mind. I don't know if you have one of those for your printer. Um,
I don't have one, but would you, I saw that you guys recommended a 0.8. Would it be worthwhile me getting one?
um, I mean, it prints fine with a zero point 0.6 and you can print with zero point 0.4. It's just because we have so many fillers that it can like, you know, it just makes it easier and less finicky if you have the bigger nozzle.
Hmm.
So, and it prints quicker. But yeah. So what nozzle size do you have for your printer?
Right now I think I've got a 0. No, it's 0.4.
It is a
0.4.
0.4. All right. Well, I can modify the part and then to work with a zero point 0.4 for you, and then I'll send that to you.
Oh, cool. Okay. What's the
Yeah.
biggest nozzle that you would recommend going through?
Well, I mean, we've printed with even like a 1.2 for like,
Oh,
uh,
wow. Okay.
yeah, when we had our CR10s that we were using a lot. And actually, we have a pellet printer as well that we usually use a 1.2 sometimes on. But we regularly print like with a 1 as well. Just for like parts that, so when we print with like a bigger nozzle, it's because the part isn't going to be like for cosmetic, it's mostly just functional. So maybe it's going to be out of the way or something like that. You just need it to work. And so yeah, we'll usually use a bigger nozzle because it gets it done faster and it works beautifully.
Okay, awesome.
Yeah, I don't know if Bamboo offers a 1. I know they do the zero point 0.8 because I have that. But
Oh, okay.
yeah,
Yeah.
so
I'll check that out.
but yeah, I'll work on the model. I might be able to get it to you today, or if not tomorrow, where it can work with a zero point 0.4 pretty easily.
Oh, awesome. That'd be great.
Yeah,
Yeah, that'd be
yeah,
amazing. Well,
all
thank
right,
you
Jim.
so much, Rocky. I really
Of
appreciate
course.
you giving us your time here today to step us through these things. I think it's really exciting to try this new kind of exotic filament out and try printing a heatsink, which
Yeah,
every time I tell someone about it, they're like, "What? That sounds crazy." But yeah, I think it's going to work out really well. But thank you so much. Have a great
of course.
evening over there, and I'll let you
Yeah.
know how it goes.
All right. It was great getting to talk with you, Robert. And
Yeah,
yeah, have a good day and happy printing.
thank you so much.